Alright, welcome back everybody to a new video. Today we're going to be taking a look at an easy problem known as valid parentheses. So this is a very common problem, usually asked during phone screens or online assessments. And for me personally, I've actually been asked this a couple times, so it's definitely a question worth learning. In any case, let's take a look at what the problem asks us to do. So we're given a string S and it contains all these characters. So these characters are just parentheses. We have an opening parentheses and a closing parentheses. And we have this for the other pairs as well. We have the curly brackets and these square brackets. So as you can see, all these brackets have a corresponding closing bracket. We have open and close. That's key here to understand. And the ultimate goal is for us to determine if the input string is valid. And in order for us to determine if the string is valid or not, we have to follow the criteria below. So the open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. Essentially, if all this criteria is filled, we will return true. Otherwise, if one or all the criteria don't match, then we will return false. It's that simple. The output is just going to be a Boolean of true or false. To get a better understanding of the problem, let's take a look at the examples. So for the first example, you can see we have an open parentheses and a closing parentheses. And so if we look at our criteria again, open brackets must be closed by the same type of bracket. So we have two regular parentheses here, and they must be closed in the correct order. So this one's pretty simple. As soon as we encounter the open one, we immediately encounter the closing one right next to it. And so what this means is that these parentheses will close each other out, so we can return true. Now, let's say, for example, we reversed it. So we would have the closing bracket and then an open bracket. In this case, we would actually return false because, as you can see, this opening bracket is not being closed in the proper order. There's no way we can close this bracket because we need to have an opening bracket preceding it. And so the reason this would return false is because it's simply in the wrong order. So now let's take a look at example 2. So similar to the first, we have our opening and then closing bracket, and as you already know, these will close each other out. Then we have the opening and closing square brackets, which again will close each other out. And then finally, we have our opening and closing curly brackets, which will of course cancel each other out. And so this returns true because we know each bracket of every type will get properly closed out in the correct order. And then finally, let's take a look at our third example. So this one is going to return false simply because we have our opening bracket and then we have a closing bracket, but this one is the square type bracket. So because these aren't the same type, they will not properly close each other out, so this will not work, hence why we return false. So hopefully this problem is making sense. Remember, a bracket can only be closed by its corresponding type of bracket. So regular brackets with regular closing brackets, square brackets with closing square brackets, curly braces with corresponding curly braces. The type matters here, and also the ordering does as well. Now, what if we had something like this? As you can see, we have two types of brackets and they seem to be closing each other out. We have this one being closed out by this one, and then this curly bracket being closed out by this one. The thing is, this example actually does not work. It will return false. And the reason being is just because the ordering is wrong. As you can see, we have our opening brackets right here, but then the first closing bracket we encounter is this one. And so if we're taking this closing bracket and trying to close out this one, it just won't work. Remember, they have to be of the same type. So while yes, there are the corresponding closing brackets for each type of bracket, the ordering is wrong, hence why we return false. So now that we have a better understanding of the problem, we can determine an algorithm to best solve the problem. Now, one of the things you might have noticed is that our problems will have to start with a opening bracket. And the reason for this is because in order to close a bracket out, we first need to have the opening. So our problem will never start with a closing bracket like this. Because imagine, let's say we start with a closing bracket, we could have any number of opening and closing brackets beyond this. Sure, these can get canceled out, but this one never will. So our problem can never start with a closing bracket of any type. So our problem has to start with an opening bracket. And once we have an opening bracket, we can pretty much have any number of opening brackets so long as we close them out. So as you can see right here, we have 5 opening brackets. So as long as we have 5 closing brackets, then this string is valid, because these will cancel out, and then 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 finally these will cancel out. So this string will return as valid. But let's say we had an extra closing parentheses on the end, then this would be false, because then this one will be left over. It will not have its corresponding opening bracket, thus cannot be closed out, hence making the string false, or not valid. Also, one last thing to point out, looking at this new example, notice how when we close out a parentheses, we would always check it against the most recently looked at opening bracket that we've seen. In this case, this one. So then these will close out. And again, this bracket is not going to be checked against this one. It will be checked against the most recently looked at, in this case, this square bracket. So then, again, these will cancel out. And then finally, this will cancel out with this. And so we need to start brainstorming ways in which we can make sure that the proper ordering is maintained as we look through our string. And so like I was just saying, whenever we encounter a closing bracket, we always check that against the most recently viewed opening bracket. And so whenever we encounter a closing bracket, if we're always comparing that to the last seen opening bracket that we encountered, then that should sound familiar to you, because that's essentially what a stack is. And so just drawing it out for you, using this example that we just looked at, our stack collects all the opening parentheses. So we'll start with our normal one, our square, and then finally our curly. And so when we encounter our first closing curly, we will only ever look at what's at the top of the stack first. And so when you start to visualize it this way, it starts making more sense. Because when we encounter this closing bracket, we will cancel this one out. And then when we see this one, what's at the top of our stack? The square one. So we will close that one out. And then finally, the item at the top of our stack is this normal bracket, which is our last remaining bracket that we need to close out, like so. And the reason the stack works so well here is because it follows something known as LIFO order, which stands for last in, first out, which perfectly captures how this problem works. The stack is the perfect data structure to help us manage the opening and closing parentheses that we encounter as we move throughout the string. This allows us to effortlessly retrieve the most recent opening parentheses when a closing one is encountered. Essentially, at the end of our problem, if our stack is empty, then we know we've closed out every parentheses, and if it's not, then we know that that is not the case, and so we can return false. One of the last things to consider for this problem is, how do we know when we encounter a closing parentheses to match it to its proper opening parentheses? Well, that's where our hash map comes in. So looking at the second example again, let's say we come across this closing parentheses. So we would have to have a hash map that essentially takes that closing parentheses as a key and then returns the value of the open one. So if we ever encounter this, we look to the top of our stack to see if we have this. If that's the case, then they can cancel out. The same holds true for the other types of brackets. So we have our square brackets, and then we have our curly brackets. And so this is the basic hash map that we will create for our problem. One last thing, the time complexity for this problem will be O of n. And the reason for this is because we'll be looking at potentially n brackets, where n is the number of brackets in our string. And then the space complexity will also be O of n. Because when we create our stack, it could, in the worst case, hold upwards of n items. All right, so hopefully all that is making sense. Now with that out of the way, let's take a look at the code. All right, so first things first, remember we are working with a stack. So the first thing we need to do is declare our stack. Now in the case of Python, we can just simply declare an empty list and then pop from the end, essentially mimicking a stack data structure. And then the next thing we have to worry about is mapping all of our closing parentheses with our opening. And so you can probably guess what I'm going to be doing here. We'll have our closing parentheses key here, and then that will get mapped to its corresponding opening parentheses. And we will do this for all the bracket types. All right, so as you can see, we have all three pairs of brackets here. So now that we have this out of the way, we simply have to start iterating through our string. So we can start with a simple for loop, iterating through each character in the string. So now we have to start doing a few checks. So the first check we can make is to see if the current bracket that we're looking at is an opening bracket. If it is, then we can push it onto the stack. So that'll look like this. If c in mapping dot values. Essentially, if we encounter an opening parentheses, we push that onto our stack, or in this case, append it. If that is not the case, if it is a closing parentheses, then we will fall into this check. LFC in mapping.keys. If this case is true, we will fall into another check. In this case, we want to see if the stack is either empty or the elements at the top of the stack does not match the current character or bracket we're looking at. So if our stack is empty, or if the bracket at the top of our stack does not match the current bracket that we're looking at, then we just return false. And then we will add a final fall through statement right here where we will also return false. And that's pretty much it. So once we break out of this for loop, we pretty much check again if the stack is empty. If the stack is empty, that means we've properly closed out every single bracket in our string, which means that the string is valid. If there were any brackets left over in our stack, then this would return false, which would mean it is not valid. And so this is the solution code for our problem. So I hope you learned a lot, and I really hope you understand why we're using the stack data structure for this problem. You see, stacks are actually very common in coding interviews, so much so that I would consider it a common coding pattern. The thing is, you have to get good at being able to determine when to actually use the stack in a problem. So how can you identify when to use the stack or not? Generally speaking, if you can identify some kind of order within the problem, then you can see if stacks are a good fit. In our case, the order was tracking the incoming open parentheses and then closing them all out with their corresponding closing parentheses. Now, the ordering doesn't have to be strictly ascending or descending, but as long as there's some sort of order to the problem, or that the problem is asking for, then maybe look to see if a stack can help you out. So anyways, that's the valid parentheses problem. I hope you learned a lot, and I'll see you in the next one.